This. Thank you so much, everyone. 3 years. It's been 3 years since the last Try Swift. I can't believe it. It's like the last 3 years didn't exist. But I'm so glad we're back together in person at this point. Cool. Now, where was I? Oh yeah. So I was asked to do this talk in English, which feels a little weird after so much really fantastic talks in Japanese now. But I just as a heads up, I do speak a little bit of Japanese. So if you want to come have a chat with me afterwards, please do. So without further ado, this is a bit of a special kind of talk experiment I want to try and do. My idea here is like, I've got a lot of stuff I'm really excited to do this year, and I kind of want to like just use one of my Swift libraries I built a little while back to kind of like talk about what my current mindset and motivation is when it comes to building software, especially in Swift. So without further ado, let's go. Really quickly, who am I? I just had a nice introduction. I'm Tim. Some people call me Tom, especially at Try Swift, because it's a Try Swift thing. Nice to meet you all. Like was just said, I like doing iOS. I like doing video games. I try to stream them sometimes, and I like doing karaoke. And that's pretty much it. Yeah, very simple. Oops. Like maybe said earlier, I did actually present at the very first Try Swift in 2016. I did a talk on core graphics, and I tried to do it in Japanese, and it was very nerve-wracking, speaking in a different language. So huge props to people who do that on the comment side. I can't believe that's iOS 9 there. That is 7 years ago. I cannot believe how fast the time flies. Like, I look so young and energetic. And stuff like that. And now look what happened. Yeah, so I can't believe it. But it's a really good thing to point out. This is like, it's amazing that Try Swift has been going so strongly for so long. Like, not many conferences can say that. So I definitely wanted to say this is fantastic what Try Swift is doing. I'm just coming up in about 2 weeks. I've been in Japan for a whole 5 years, which is just terrifyingly crazy. Where did the time go? In my time in Japan, I've had an opportunity to work at 4 fantastic companies that let me learn new things about software in different ways. The first one was I worked at Macari here, so I used to come up and present here sometimes. I used to work on the original iOS app, not the new one that came out late last year. And that one, being a 2013 derived code base, that was like a mixture of Objective-C and Swift, and everything was in UIKit. And it was moving towards being fully Swift at the time. Then after Macari, I have a buddy who's making a game over here called OSS. And so he has a little game studio here in Japan, and I went and worked with him for a bit and to work on iPad OS integration with his game. But the architecture for that one, that is not iOS. That was C# and OpenGL, which is crazy, just coming from like UIKit and going straight down to OpenGL. Like it kind of puts in perspective like how nice having UIKit and now Swift UI is, just because OpenGL is a bit crazy. And they assured me that they're actually working on this really crazy new graphics abstraction API. They'll let them remove OpenGL and map it to Metal on Mac and Vulkan on Windows, which is sounding really cool. After that, I worked at Drive Mode, which is a subsidiary of Honda, where we built a little Bluetooth app called Honda Road Sync, where you could pair your phone to your Honda motorcycle, and then as you're driving, you could operate your phone with a control on the handlebars. And that was really fun to work with, and it was super cutting edge. So we did Swift. Swift was the whole thing. Even the Bluetooth layer was Swift, and then Swift UI completely for the UI, which was kind of hard because supporting Swift UI on iOS 13 is a roller coaster of regressions and then progressions and then more regressions, and then it was really good fun, but it really puts in perspective. And then finally, at the moment, I'm working at nothing other than Instagram. Instagram has a very small product team here that I'm a part of, that we're shipping new features and bug fixes to the client app. So we have iOS and Android engineers over here. They're some of the loveliest and most talented people I've ever worked with, and as you can probably imagine, Objective-C, Instagram is still for the most part Objective-C and UIKit. So it feels like over the past 5 years, I've done like one entire rotation, one lap of the iOS developer experience, starting from like Swift and Objective-C and ending at Objective-C, which is absolutely crazy. But at the same time, it's been fascinating just to learn so much about different ways about software is being made. Cool. And so when I'm not working on apps for companies, I'm working on my own little app, which is a little comic book reader called iComics. As you can see here, it's a bit old. I made it for the first iPad. The idea here is basically a lot of folks are trying their best to like re-release, get the legal rights to re-release really old comic books now that they're out of print as like a DRM-free publication. And so while there's the content like that, you need software to consume it on iOS. So my goal of this app is it's like QuickTime Player for comic books. You provide the content, and I try and create the most like nice reading experience that's possible on iOS. But as you can see, designing it for the iPad 1 with its nice skeuomorphism and gradients and like triple bezeled bubbles and things like that. It was being designed for the first iPad. The app was designed for single core processors and only 200 megs of RAM. And scaling it has been kind of tricky. So something I want to do this year is I'm going to start a new one called iComics 2. I'm going to give it a better name. iComics 2 is the placeholder. And I've got a quick mock-up of what I'm going to work on here. And there's a bunch of stuff that I want to like try and research this year related to like Swift and just iOS engineering, modern iOS engineering in general. Stuff like, yeah. And hopefully this is stuff I could talk about down the line. Things like going fully to Swift and then using all the fantastic new features of Swift. Like async await is a game changer when you think about it. Like GCD and NS operation are really easy to break. And so I'm really excited that async await makes like concurrency code on iOS so much more easy. We're also at the point now where like comic books are getting so big and like, there's so much pixel data now that like I feel like I'm running up against limitations of UI image view. So something I'm looking at is actually doing a metal renderer, so I can go down to the shader level and do like per pixel sampling for this. So like super, so it's like super going down and down the rabbit hole. But it like in some like Apple's got some really good code for how to work with metal, and once you learn how metal works, like it's really good fun and really easy to work with. Something I'm really interested about is like, I'm not sure if other people have noticed this, but like in iOS 16, Apple seems to be going more and more towards like a very crisp, like flat design where they use like negative space instead of separators for design. So something I want to try and run with that is, can you make an app without any separators? Like, could you just use negative space and not clipping views to make something that's like, it looks really, really clean because there's no separators? Might be impossible, but it's probably worth a try. Another thing really cool is like, hopefully a lot of people realize this, is like moving from CocoaPods to SPM. Like if you can do that, that means you can have like a really complex app and no like Ruby environments. It's just download, open an Xcode, run, and that sounds really appealing. You probably still need Ruby for like build tools and the likes, but to do that, to get at the developer state with SPM, I'm really excited for that. And another thing you can do with SPM is you can use it to like do to modularize the code a bit. At big companies, I hear like Google uses things like Bazel, and at Instagram we use something called Buck. The idea would be like, could you make like a little mini Buck to modulate your dependencies like that without having to do like a full-blown complex build system on top? And it's a bit of a stretch goal. Like I really like Mac Catalyst. Mac Catalyst is a really cool tool. It makes releasing your app on Mac so easy. So I want to look into that. And one final thing, a stretch goal, is potentially a Windows version. I was thinking about using the OSS engine, or maybe Swift on Windows is getting really good right now. So there's a bunch of ways to start thinking about how can I take an iOS app and make it cross-platform. Cool. The thing I want to talk about today, though, is going through all the companies I've worked at, I definitely see that there's this sort of kind of like, there's sort of like a trend for how apps are architected. And so for the most part, when you think about software, what software is you've got some kind of state, mutable or immutable in memory, and then the UI is synchronized with the state somehow. And there seems to be two ends of the spectrum. You've got certain companies doing just completely manual stuff. Like if you want to update the UI state, you use a delegate. And basically, whenever you need to like reflect state between two views or view controllers, you use a delegate. And so everything's just like a manual pipe from start to finish. Manual pipes everywhere. And the good thing is this is super simple. This is like 2008 iOS development, so super simple stuff. It's very easy to debug because everything's like a function, you can breakpoint it very easily. But the problem is there's a lot of boilerplate, a lot of piping, and it can become unstable because if there's like different ways to update the state, you have to account for all of that, which means like you'll start having like state issues. On the other side is definitely what we're trending towards with things like Swift UI. Is we've got the reactive sort of like Combine and RX Swift sort of ones where state is just in memory and you subscribe to the state, and then the UI updating is like a reflection of just the state changing on its own, which is really cool in the sense that it means that you basically cover all your bases really automatically. But the downside is it's very hard to learn. It has a very high learning curve, mainly because it abstracts concepts away from like. It uses like its own terminology and concepts, and so it's really good in how efficient it is, but also kind of hard about how tricky it is. And the one thing that's really tricky is sometimes it's hard to debug if you do it in such a way that you can't set breakpoints. Finding out when something's not updating, or like when something's updating too often, which is the case in Swift UI a lot, that's when it becomes tricky. So I'm trying to, with my app, I'm just going through the design right now. I want to go right down the middle. I want something that's like as simple as delegates, but not as like boring as delegates, but at the same time, not too magical that it becomes hard to work with. So something right in the middle is what I want to try and do. And so that's what I want to talk about with Beeline here. So this is a little library I made about a year ago. I'm really excited about it, as you can probably tell. And I'm hoping that from what I'm talking about here, this is hopefully something that can get you a bit excited and to challenge your perspectives about software development as well. So just before we continue, I kind of just want to really nail that home. Like, something we always forget about is that this stuff is hard. That's why the salaries are so good. So just remember, like, there's never a 100% correct solution. Every solution is valid in its own separate way. And usually what happens is the best solution is one that the users love. And so if you do it in such a way that you delight the users, that is what I would consider like the best way. But the problem is that comes up against time. And so that's why tools like Swift UI are really good, because they let you achieve better results with much faster iteration cycles, so you can do a lot better work in less time. But at the end of the thing, what I'm going to show you might be good, but it might also be bad. I think it's good. But the idea is, hopefully, either way, it's going to be interesting and you'll learn something new, and that's what I want to do with it. So without further ado, let's go. So hopefully you've seen this before. This is a pretty standard iOS pattern where you tap a button, you create a view controller, and you get the current navigation controller, and you push it, and that's it. And this is fine until it's not. Usually what happens is like something I want to say is like sometimes in the iOS community you'll see people like, no, you shouldn't do that ever. That's a bad pattern. You shouldn't do it. And it's kind of like, well, no, you can do it. It's fine. It's just, if you do it, you've got to realize that there are trade-offs. And like certainly, I think for most cases in like simple apps, this is just completely fine. This is when it starts to scale up and become more complex. This is when it becomes a problem. And so one problem is like redundancy. Let's say you have like a bunch of view controllers who are trying to go to the same view controller, and so you're instantiating each one in each different view controller. So now you've got redundancy, which you can fix with with a view controller factory or something like that. But at the same time, as you can see, you're introducing more redundancy. Or something else is like the tight coupling. Like certainly some view controllers, especially at biggish companies, might have a lot of dependencies that you need to instantiate the view controller. Like you might have a data source, a delegate, an event logger or a performance logger for debugging, and then like a networker. And so you've got all these dependencies that the current view controller has to know about in order to get this view controller to be instantiated. So this is like, this view controller has to know it's this other controller's entire story in order to work. And so that becomes really kind of like messy, because now this other view controller has all this extra dependency management code that it shouldn't really have. And then going further, this is where it kind of like really falls apart. It's like when you start doing deep linking, like if you want to have an app with like a widget, so the app could be in any state in memory right now, and then when you tap like the widget, it has to go into the app, work out what's visible, and then tear that down, and then work out what needs to be visible and set that up. And then maybe at the end, there's like some kind of state transition. So then it has to also know how to like link everything together and animate it. And I'm going to drive like the transition home really now. This is an effect I've been working on recently. I've been doing a nice book unfolding animation, which I really like. It's just normal UI views, so nothing too crazy. But the problem is right now these two view controllers are really tightly coupled, because they have to share so much information to say like, I want to open this book, so I need this thumbnail, this position, and then this has to be like, okay, I need you to, when I start playing, hide the thumbnail in the first view controller so it looks seamless. There's a lot of like state coordination, and so it becomes very easy for one view controller to completely own another view controller, and they should be completely separate. And so it's like, when you think about this, it's like, well, this is not the job of view controllers. There should be some object here that controls all the view controller state on your behalf, and it's not spread out between all of your view controllers. And so this is not a new pattern. This is something that's been in Viper, if people know the Viper pattern, forever. It's the R in Viper. It's the router, where you have like a single object in memory who's in charge of your entire navigational state. It knows exactly what's on screen, and if anyone anywhere in the app wants to go to some other screen, it knows exactly what has to tear down and what has to put back up for that to happen. And so normally a router looks like this. You instantiate it, and you give it a root view controller, and then when you call like show detail on it, it just takes that root view controller and reconfigures it. And that works. And then but the next tricky bit is like, how do you get this router object to every view controller who wants to do routing? And so there are a lot of good ways. Like you can use dependency injection, which is really good. Vincent Prade, who is a really cool Swift, I was going to say content creator, but that's doing him a disservice. Really good. He does like really good YouTube videos about how to use Swift really well. He actually showed a really cool technique where you can use singletons as default parameters in instantiation. So as long as you don't need to do any overriding, you can basically hide the injection away automatically, which is cool, kind of like, it's really cool, because it means like you can get like really effective usage of singletons without actually doing the naughty things about like implicitly embedding singletons. But at the same time, that's still a lot of code. I have to retain the router. I have to like hang on to a reference to the router. And so it's like, yeah, it works, I guess, but surely there's a better way. And so, and finally I was like, oh, hang on, I think I've got an idea. So there's this really cool method in UI view controller, at the UI view controller level called show. And it's really nice because it's like a semantic intent behind how this view controller should be shown. So you again create a view controller inside the view controller, and you say show, and then what it does is it goes up the view controller chain and says like, can you show this? No. Can you show this? No. And then if you come across, depending on iPhone or iPad, you might be a split view controller or a navigation controller. It's like, can you show this view controller? And the first one up the chain will go, yep, I can show it, and that's how it works. And that's really cool because it means it's really decoupled. It's like your controller just broadcasts an intent, and maybe someone will listen, and maybe someone won't. And so it's kind of like there's no actual like tight coupling. And I was like, oh, okay, well this is actually pretty straightforward then. Let's just do that and just get rid of the view controller bit. Let's just use an enum. And the cool thing about Swift, I love, some coming up on really sweet Swift features, I love the fact you can have associated values of enums, because now I can say like, I want to show a view controller, and here's all the state that the previous view controller wants to give to this one, so we can just move it across and it knows what it needs to show. But we're not doing any tight coupling here. And then as you can see, we can just add an extension to UI view controller itself saying show this root as like show one of these enum values, which you can subclass here to create custom ones, and then that's all it does. And then so when you call show, it does the same concept as the show view controller method, where it just goes up the chain until it finds a view controller with an associated router, and it says, okay, this router knows how to show this one, so let's just give it to that one, and then that one will handle the new state updating. But the problem is, how do you associate a router with a view controller? There's a very good answer for this. That's my boy, my favorite thing, Objective-C, baby. Woo! So I like to think that Objective-C and Swift both have really good advantages. And I'm definitely in the opinion that if you can just use everything to achieve your goals, no matter what, like, it was fine. Like, some people might say like we shouldn't be doing this in like using Objective-C features at this point, but definitely I think like if you can use the best of both worlds, you'll be in a good spot. So you can use associated objects, which means you can actually attach an NS object to another NS object in using the Objective-C runtime. So all we have to do is create a new property on UI view controller called router. At that point, now every view controller could potentially have a router. It could be nil, in which case it'll just go back up the chain, but you just give something a router. So then all you have to do now is at the start of your app process, you can just assign the router to the top level root view controller. And this is really good because maybe if you're doing scene delegates, so you can have two windows at the same time, you can give separate routers to each one. So each view controller can maintain its own state separately inside of the main process. And then all we have to do here is there's definitely, like, we could debate this over beers later. There's definitely a thing about saying, like, should you use composition over inheritance? But in this case, I think just having the ability to subclass a base router abstract class lets you then just inject on top of it any kind of custom logic you want. So as you can see here, the base class has an abstract function called just show route from source view controller. And with that context, you can work out exactly what is being shown, and conversely, if this thing is the right router or the wrong router for that. And then actually using the context of the previous view controller, we could either detect the navigation controller ourselves or just grab the navigation controller from that view controller and append it. And so this is actually not that complicated in the end, but there you go. Right away, we've got, like, through a router that's going up the chain, we've got the ability to then just regenerate the same view controller, completely decoupled from each other. It's pretty dope, I think. Cool. All right, so what else? So a nice side effect of this is because it's up the chain, you could have separate routers. Like, certainly something that happens when you have, like, giant apps is you have giant lists of state. And it will sometimes be contained in one class. So you have like 100 lines of a giant if statement. And that was something I wanted to avoid here. So something you could potentially do is you could have like you could have sub-routers, nested routers for parts of the app. For example, like the main app doesn't have to know the state about a settings view controller, which is all modal and self-contained. So you could apply a settings router that whenever a child view controller below that calls calls show this route, the settings router can intercept it, but if it's something bigger than that, it goes up the chain to the top main app router, in which case here you've got a very good way of modularizing your code so it's specifically for specific sections, and you can make it just really nice and manageable as a result. And just one last thing, like what about Swift UI? Let me just take this opportunity just to talk a little bit about Swift UI. I do find it kind of sad. You see like interactions on Twitter and the likes that I thought I unplugged it just now. It seems to be like UI kit versus Swift UI. It's like I'm either going to go 100% UI kit or 100% Swift UI, and like something that people don't really, I think, don't really appreciate. But the really cool thing is they work really well together. And so I'm not going to take credit for this thing. I actually just went to iOS Conf Singapore last week, and Adam Bell, who's a fantastic, absolutely fantastic presenter, and was also there with me at TriSwift 2016, talked about this as well, and how he was able to do some fantastic work really quickly by being able to have Swift UI generate the main UI content, but then on the UI kit level, you can then apply things like really granular gestures and animation that then just control the container the Swift UI is in. So in this way, you can get fantastic sort of like UI without, with really, really quickly with Swift UI, but at the same time, you still get all that granular control of UI kit. And so going back to that, like for iComics 2, what I'm considering about here is you could definitely do things where you have like Swift UI hosted, like these mini view controllers on top of the layer that have like all the complex UI that would be so much pain and suffering to do in UI kit, and just do all that in Swift UI. But then the underlying one, the metal renderer, the thing that's going to need like pixel precision control and performance to scroll perfectly and the likes, that can be UI kit, and then you can accept these nested Swift UI controllers on top of it. So I definitely think moving forward, certainly at this point in time anyway, if you want to make a really good app quickly, you should definitely look at leveraging Swift UI by default, but then when Swift UI proves that it doesn't give you as much control as you need, you can just drop down to UI kit. So in that note though, so the router, like Swift UI itself has a really good navigation system now, especially in iOS 16 with navigation link. So this is kind of only really necessary if you're doing hosted view controllers and interfacing with UI kit controllers. But you can definitely just inject the router property as a Swift UI environment variable. That way you can just access it from the Swift UI view layer. But the problem is that this is one problem. Because it does that, because Swift UI can't easily find out if it's being hosted by a view controller, you have to do it contextless. So the router itself will have to work out on its own where we are in the state and what view controller is visible right now. Like I said, you can't detect UI hosting controller from Swift UI. But someone actually did do an answer on Stack Overflow where you could like subclass UI hosting controller and have it as like an implicit environment variable. So whenever you use that view controller, whenever you use like that particular host of view controller, like the hosting view controller is visible there. So on that note, you could do something like that and then just inject the router value from there. And that way, from the Swift UI level, you can tell the view controller's router extension to show, and then it'll go up the chain. And so that's the library. Hopefully, just have a look at it. Come have a look at it. It's on github.com/timoliver/Beeline. Please take a look at it. Really quickly, just why did I give it that name? So I'm having a real hard time giving names to Swift libraries because they're usually all taken. Like if it's like, I looked like router was taken on CocoaPods, router kit was taken on CocoaPods, and so I feel like because there's no namespace particles, all the good names in CocoaPods are being taken now, and so now my names are getting more and more like metaphorical. So a beeline is like an English term for like just going straight for a thing. Like right after this, I'm going to go straight for those cupcakes. Like I'm going to make a beeline for those cupcakes. So that is the terms of like that I feel like made sense for the router. But like I'm trying to come up with other names for Swift libraries this year. I'm still having a lot of trouble. So if anyone wants to help me with that, go for it. Thank you. And so finally, let's do a quick summary. What I want to kind of say here is like what I did here basically was I saw an existing Apple API mechanism and just refined it a little bit more. Something that I like to do when I do software is I look to see if Apple's done it before, and then usually just go that way. Because if Apple's spent a lot of time working out how this API will work, that's usually a good template for when you design your own APIs. Just go with that. That way, and when you do that as well, that means other developers will find it very intuitive. Because if they're used to Apple's APIs and you can make your APIs feel the same, it becomes very intuitive. And certainly APIs like Metal and the likes, that you can see that Apple likes to use extremely standardized terminology. So when you hear the same word somewhere else, you already know exactly what it does. Again, this is actually not a lot of code. Like Beeline without the comments is like 40 lines of code. But the idea is basically we're leveraging Apple APIs just in a new way. And the cool thing is, like, it might be simple, but it's very powerful at the same time. And this is something I definitely want people to like think about when they're working on designing software now. And then something I thought about at the very end, I was like, well, I only did this to come to use a router, but like this is a very powerful mechanism, being able to like reconcile global objects through a view controller chain. So you could use it for like a really budget dependency injection system. So if you need things like a database or a networker that has to live at the top level, you could use this to dynamically reconcile it without using something a bit more complicated or complex. And at the same time, like the idea here is, the goal here is like make it really modular, decoupled, and testable. Like I think that the mantra for designing good software is just make sure everything's decoupled. Every object is like, it's got like one purpose, defined inputs and outputs, and then if you just stick to that mindset, everything you build will be really, really maintainable and really easy to work with. In any case, I hope this gave you all some new perspectives. I hope you found this useful. And I say this every talk, I hope you go forth and make something awesome. Thank you so much.